All right, kids, we're in Unit 4, Lesson 1, Algebra 2. We're going to talk about quadratics. Quadratics are, remember those parabolas, right? They have squared term as the highest power in the equation. That's what a quadratic is. It's a second degree polynomial. Let's turn that off. What's happening here? Oh, my goodness. Oh my goodness. Google Pay something, something, something. I don't know. Go. Oh, what's happening? Well, that was fun. Let's continue on. Did you enjoy that? Okay, so we're gonna kind of get some definitions. We're gonna talk about some stuff. We're gonna get some little small formulas, and we're gonna do an example, and then we're gonna be done. It's gonna be a pretty short one here that we're doing this. So this is the standard form of a quadratic function. F of x equals ax squared plus bx equals c. All right, so we can tell a few things from this. Now, I kind of put an example. Now, you're like, is this one? Well, this one doesn't have any numbers. So this one isn't anything. This is just the generic one, right? It's like that y equals mx plus b as the slope-intercept form of a line. This is the same idea here, or the standard form ax plus b y equals c. And remember all of that stuff. So it's like that, but for quadratics. And this is what tells us it's a quadratic. It has the highest degree, or the degree of the polynomial is squared. And so that's what we go. So on this little, picture here, we've kind of got this so we can kind of get some ideas. So there's a couple of things happening. First of all, we have a y-intercept. That's where this parabola shape crosses the y-axis, same as it's always been for all the other things. And we can find it just as easily as we can for a linear function. If the quadratic is written in standard form, then that y-intercept is the c, just like it was before. So that is where that is. So let's go ahead and write that out here. For the y-intercept, it is the point 0 for the x, right? We don't go left or right any, and then c. And that's always true. If the quadratic function is written in standard form for the y-intercept, we've already got a point on the deal. Blapo, y-intercept, easy peasy. Now, the axis of symmetry, where is that, first of all? Well, that is this. Let's see. Let's do this way, I think. Right? And then right? So the axis of symmetry is what it sounds like, right? You probably know the word symmetry. That's where if you take and you fold over the shape, then it's the same, then they meet up and it's the same, right? So it's where it matches. So that's what that is. So it's right here in the middle. So the axis of symmetry is actually really easy to find with a really easy formula, okay? So if your quadratic is in standard form. So if it looks like this, where it's in descending order, so x squared, x, no x, right? All lined up like this, and a is not 0, because if a were 0, it wouldn't be a quadratic, right? We should put that as a little, add that as a little note over here. A does not equal 0. It's kind of a no duh thing a little bit, because again, if a was 0, then it would be linear, right? It wouldn't be a quadratic anymore. But so for the axis of symmetry, the formula for that is really easy. Now, the axis of symmetry, you'll notice, is a vertical line. So the equation for that line is going to be x equals something, right? Because vertical lines all have the equation of x equals some number, right? That's always how a vertical line's equation looks, right? Very simple. So it's also very simple to get this done, because we do negative b over 2a. And that's this a, and this b. Let's take this here and here. So we get the axis of symmetry from that. So now what is the vertex of a parabola? Where that is the point where the axis of symmetry crosses it, right? So it's kind of the very bottom, or if it was an opening up parabola, it would be the very top, right? So it's one of those two things, right? So to find the vertex, well, the x part of the vertex is this x right here. So to find the x part, we just do negative b over 2a. And you may have already guessed how to find the y part. Negative b over 2a. So it's the same as the axis of symmetry. That makes sense, right? Because that's the x part of this thing, that equation. The x part, all x is all the same all along that space, right? So to find the y part, you take and you plug it in. So we plug in negative b over 2a m for x into the equation, and we solve for y, or solve for f of x in this case, right? So we're going to write, and we'll do an example to kind of clean this up in a minute, but it would be f of negative b over 2a. So we plug in whatever we get for x into the function, and then out will pop the y part of the vertex. Now, what about the maximum and minimum? So the maximum and minimum, it's very important that we understand that what we're talking about is, so the axis of symmetry is in the x direction. X direction. In the maximum minimum, we're talking about in the y direction. So either the highest point or the lowest point. Now, how do we know if it is a maximum or a minimum? Well, if it's an opening up parabola, then it's a minimum, right? Because it would be the lowest point. If it's an opening down parabola, then it would be a maximum, right? Because it's the highest point, right? So you find it the same way. So it's the y direction. You may have already, if you're slowing down and thinking through what's going on, you might just maybe have figured out how to calculate this. If not, let me tell you, it's just the y part of the vertex. That's it. So it's just the y part of the vertex. So it's just the f of negative b over 2a. All right, so it's just the y part of the vertex is the either maximum or minimum, depending. So let's do an example and kind of clear up all of this stuff. Go ahead and get that copied down in your notes, and we'll hit the example. So here is the example. So for f of x equals negative 5x squared minus 10x plus 6, find the y-intercept, the vertex, the axis of symmetry, and any maximum or minimums, then graph. Okay, so let's do that here. Okay, so first thing I want to, this is kind of one more note. If you look at the a part, if a is positive, then this parabola opens up. But if, like our example here, if it's negative, then the parabola opens down. And you can also figure this out with kind of the last step we're going to do here in a minute, which is going to be doing a table and graphing the thing. But that's how to do that. So y-intercepts. Well, the y-intercept's easy. This is already in standard form. We've got ax squared minus 10x plus 6. So the y-intercept is going to be the point 0, 6, right? So let's go ahead and put a dot there. So 0 and 6. 1, 2, 3, 4, 5, 6. Put a dot right there. We're starting to build our parabola. So far, so good. So far, it's easy peasy, right? Then the vertex. So, well, the vertex, axis symmetry, and maximum minimums, we're kind of all going to get from the same place. To get the x part of all that stuff, we're going to use that formula, which in case you forgot it already or it's not in front of you still, it's x equals negative. This is the y-intercept. Okay. Negative b over 2a. So we're going to plug in our b, which is negative 10. Watch those signs. That's still an easy place to make a mistake. Over 2 times a, which is negative 5. So now we've gotten minus minus. So we're going to ka-chink those. Right? And so this equals 10 over 2 times negative 5 is negative 10. So the x part, the axis, go ahead and put it over here. The axis of symmetry is x equals negative 1. So we're going to go ahead and dot that in there. I'm going to shrink my brush one more, I think. And I'm going to dot in at x equals -1. We want this line, when you do draw the axis of symmetry, make sure you do a dashed line. Oh, look what I'm doing. Okay, so I'm not going to be able to make it quite as pretty. Let's try again. Do a dashed line because, and it means something different in this context than it does in like inequalities. What it means here is that this white bit here that I'm drawing on here with a dashed line is not a part of our graph. It's just a reference mark, right? And so that's what that means. So there is another piece of our answer. Oops. That's a little crazy fine. That's a little better. Easy peasy. All right, so now we know a piece of the vertex. Now we need to find the y part of the vertex and the local maximum, right? Because this is going to be opening up, right? So the y part, we're going to find f of this thing right here, which we just calculated is -1. So we're going to find f of -1. So we're going to do that just like we've always done. We're going to do parentheses where the variables are. 10 variable plus 6. And then we're going to plug in this number in for x. And then we're going to just simplify on down. So -1 squared is +1. Excuse me. Did you say bless you? Did you say it? Did you just do it out of habit? Is that habit so ingrained in you? I don't know. -10 times -1 is +10 plus 6. So we've got -5 plus 16. So f of -1 is +11. Right? Makes sense. Easy peasy. Double check the notes because of all the nonsense we did before. Pause. We are good to go. So the vertex is the point. Forget it. All right. The vertex is the point -1, 11. So let's put a dot there. So -1 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to put a dot right there. Now, let's finish getting this list, and then I'll show you how to get one or two other points. So we need the maximum. Maximum is going to be at 11. Right? There's all our pieces, right? So it's this part, all the things. Now we need to finish graphing it. So here is how to figure out what points to plug in. So we've got the vertex on there. So we're going to make a little table of x, y. All right, so it's symmetric about the axis of symmetry. I know that's shocking. So this is going to be another point right there at -2, what is it? 6, -2, 6, right? So that's going to be a point on there as well. So I'm going to go ahead and put the vertex on here, -1, 11. And then we also have the point 0, 6, and the point -2, 6. So let's get a couple other points. And to get a couple more points, what we're going to do is we're going to pick one more on this side and one more on this side. So let's pick -3. How about? And +1. They're going to be the same because it's symmetric. So we only got to do one of them. So let's do, I'm going to kind of change colors here because we're getting a little full. So we're going to find f of +1 equals -5 times 1 squared minus 10 times 1 plus 6. This first part's the same, right? -5 minus 10 plus 6. -5 plus -10 is -15 plus 6 equals -11, right? So we're going to be at 1, -11. And since it's symmetric, in other words, it's the same on this side as it's the same on that side, -3 is also going to be at -11. So -3, or 1, excuse me, -11, -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put us a dot. And then the same dot over on this side. Then we're going to do our best to connect these dots into a parabola shape. Something like that. And there we go. That is some version of this function graphed. Isn't it beautiful? All right, so that's it for this lesson. We will see you in the next one. We'll continue with quadratics, getting some more tools in our tool belt and some more tool techniques and all of those things. Hope you have a great day. I'll see you in the next one. Bye-bye.